Hi folks, welcome to my 8-Bit Retro Journal. A few years ago I did a video on image stabilization on the QL and I fixed a few things, and I actually wanted to revisit that video because questions have come up in one of my other TV videos about the picture quality. So I thought I'd revisit that video. So let's go look at that. You can see currently on my supersonic monitor I've got the QL's color composite signal going, and it gives you a pretty good signal. And if I type F2, puts it in TV mode. Monitor mode doesn't really work very well in composite on TVs. You really need a converter to HDMI converter. You can see it kind of gives you a monochrome signal. It's not even a clean monochrome signal. If I shut this off for a second and change my input on to TV, you'll see that the QL also gives a pretty decent color RF signal. It's a little bit more washed out, but it's pretty good. And again, TV mode, is pretty good. And if you do monitor mode, you get it's interesting that in TV mode, the monitor mode is similarly bad, but the picture is actually shifted down a little bit, so I'm not sure. It seems bigger too. So there's something going on in the circuitry. But anyway, so this is this particular monitor. However, I wanted to demonstrate to you my other monitor, which is my Macintosh running Windows 7, and I have a K-World tuner card, which then also has composite input. And when I connect that, it's always good to turn things off when you're connecting so you don't destroy anything on your computer. So now this is the QL going into composite. You'll see that as soon as I turn the QL on, that the signal shakes. And it has what's called vertical jitter. And maybe I'll get a little closer just so you can see it better. But you can see that the picture is moving up and down, and it doesn't stop when I do F2. It's actually interesting. I forgot to. So I'm actually noticed that I've got both monitors going. So this is RF and this is composite, and obviously the RF picture doesn't jitter. So generally a problem when a picture jitters, I'm going to turn this monitor off because I'm not going to use it, and focus on this monitor. Generally when a picture jitters, it's usually interference caused through the wire somehow. And I actually discovered what the interference was. The QL has its DIN connector. You can see that it gives you red, green, and blue signal. It has ground and it has a vertical sync, and it also has a composite sync, so that's not showing in the picture. And then it gives you composite, monochrome, and composite, in this case PAL, but I'm in the US, so I get NTSC. Well, interesting part is that the American QLs do not give, pin 1 is a high 5 volts, and I'm not the only one that's had it. I've seen several folks post on the QL forum that they get a high voltage signal on the QL on pin 5, and we haven't really been able to explain it. And I think there's also folks that are not in the PAL region in South America that also had this issue. So instead of giving the composite color signal, you get a high 5 volts. But it's easy enough to mod. There's the Motorola MC 1377 chip is what drives that signal, and you can just grab pin 9, and that's what I did. So I actually modded it to grab pin 9, and instead of actually trying to put the signal on pin 1, I actually have it routed to pin 3, and then I have a switch, so I can have the same cable and I can switch between monochrome and composite. So that's kind of nice. But when I did that, I actually grabbed the signal from pin 9 and I ran a cable from under, and the two micro drives are there, so I ran a cable right next to the micro drives, and that's what's actually causing the sync jitter. I discovered that because I can actually get rid of the sync jitter if I grab the color composite directly from the RF modulator, and I can demonstrate that by doing it. So let me, I'm going to have to go a little portable with the camera. If I were to open up the QL, so you can see, it's hard to point to, but see if I can. There is there's a green wire that's coming right up from under, that's above the red wire, and that green wire is the mod that I grabbed from the chip, and it's going right next to this, right next to the micro drives, and that's what's causing the problem. So what I'm going to do is I'll demonstrate how I can actually grab that picture and from the RF modulator, and you'll see how much that picture is going to improve. So let me first of all see if I can just put my camera sideways, and I'm going to prop this up using a credit card, actually a bus card. And so I have this, I created this wire that I can grab the signal with right here. And so what I'm going to do is I'm going to grab that signal right from the RF modulator. So let's see if you can join me in finding that. So the signal, yep, here we go. It's going to be a little dodgy here. So the signal is right, it's the signal right there. So that wire right there, you can see it gives you the RF signal, and then I just need to ground that. And the way I can, one of the ways I can ground that signal, oops, sorry, is I can pull out the, let me do that one more time. Let's set the camera next to this. I'm going to pull out this. I'm going to pull out the RF as well. Okay, lifting the camera back up. So I'm going to put the, so I'm going to put pin number 1 in the ground. So again, if you look at the, I put the ground into that pin right there. So if I do that, let me go back on the stand here, sealing down the camera. So now I have this wire, and so what I'm going to do is I'm going to stick that wire into composite. So this wire is going to go, see if I can do it with 2 hands, into this one. So now I can leave the QL propped open. So let's see what happens when, let's move this out of the way. So now I'm getting the signal straight from the RF, and you will see that, there it is. And so there you go. Now what you have is a signal that actually stops jittering, because it no longer gets the interference from the micro drives. And again, this gives you a nice clear signal. So that's one way to fix it. I'm going to turn this off again. So that's the easiest way to fix it. But I wanted to also show folks how to fix it if you can't open your computer up. So I'm going to put my normal DIN plug that has composite in, and put this back on. And you'll see once again the jitter has returned. But it turns out that if you can't somehow clean up the cable because of the jitter, one way you can do this is you can filter it. And a way to filter that is to use an up and down scaler. Well, I have a bunch of these. So this is a mini HDMI to AV upscaler. I also have a downscaler. I just can't find it. So, but luckily enough, a while ago, I was trying to find a way to get RGB to HDMI, and so I bought one of these, which is a SCART to HDMI, but it turns out that SCART has many meanings and it's not just RGB, and this one unfortunately is just a composite to HDMI upscaler. And luckily I also bought one of these that allows me to do the composite SCART. So if I plug this in here, power it up, and then I have one of these. So all I have to do is plug this in here, plug this in here, and it turns out that you actually only need, so this also has input for a 5-volt signal, but as long as you have 5 volts on, on either one of these, you're fine. So this is a USB. This goes to a USB plug. All right, so now let me connect it. I'm going to turn the QL off again. So I have a cable that's going to go from here to the HDMI to AV. It's already turned on, so you can see that it's actually getting a no signal now. And then I'm going to plug my QL into that. And so now when I turn my QL on, ta-da! I have a steady signal. It's not very good though. If you really can see, it's very washed out. So I should be able to do better. And of course what's happening is you're upscaling to HDMI, losing something, then you're downscaling from HDMI to back to composite and you're losing something. So it's not the most ideal. And so another way to, but I have another device that might help me do this. So I'd gotten these things a long time ago. So these are X10 video receiver and X10 video sender modules, and so they basically just over the air send an RCA, a composite signal. And so I thought I'd give those a try as well to see what that gives me. So let me set those up. So each of those requires a power brick. The receiver one is actually bigger than the transmitter one, interestingly enough. So my receiver one is this one. That's the video receiver. This is the power brick. So I'm going to unplug this since I'm not using it anymore. And now I'm going to add these two things. So that's the receiver and the transmitter. You can tell this is the transmitter because it actually also has, it's for TVs, so it actually can do infrared as well, the remotes. So you want to, this is the transmitter, so the transmitter, I'm going to unplug my TV. And then the receiver gets this one. Let's try that. Okay, and then all you have to do, the antennas actually just have to touch. And of course we got to plug in, RCA goes in here. RCA goes in here. So they're actually turned on. So if I turn the QL on, see what I get for a picture. Ta-da! Now we get a really nice, this is actually probably the best picture I've had. So these video transmitters and receivers actually do a really decent job. Right, so QL goes into here, over the air, into the TV tuner card. And it's a pretty good picture. And not shaky at all. The other thing I was looking into, which I couldn't find, was it possible to actually use a RF demodulator? And I do have a few digital converter boxes. I have one right here. Unfortunately, so this is one of those, in the US we got these with a voucher, and this will take any over-the-air signal and convert it to composite to hook into your TV. It has a pass-through as well, but unfortunately this has no analog capability. It's only digital, so there's no way to take the RF picture from the QL and pipe it through composite. So these were the two ways that I found to do it. Basically, you either use an up or down scaler, or these are pretty cool. These are from the 90s. And by the way, the reason all this works is because certainly the upscaler that I used, this is something that's less than 10 years old, and so you know, it's the older equipment from the 80s that might have trouble with modern you know, with modern composite circuitry, because you know, they're not trying to be fully compatible. Although from what I've read, what's going on is that they're not really following this complete spec, but they don't necessarily have to, because the signal has compatible with isn't necessarily as relevant. But let me actually show you what's actually going on. So I'm going to put the jitter back in here. So I'm going to turn this off. And I'm going to plug this back into here. And just to give you a little bit more detail of what actually is happening when you encounter this. So again, this is the jittery picture. And you know, maybe a little closer so you can really see it. And so what's going on here now, unfortunately I don't have an oscilloscope, otherwise I could perhaps demonstrate this. Now there's interference in the signal, so the signal itself looks something like this, where you have the sync pulse, which is basically the synchronization signal that the circuitry is looking for, and the specs. So there's a falling and a rising edge, and a lot of the modern equipment is actually sort of because there's different variants of the signal. They're looking at the rising edge, and the rising edge is the thing that can have more noise in it than the falling edge, and so this is why some equipment like this K-World stick is. And unfortunately, I don't have an oscilloscope, but I did find a picture of what jitter actually looks like. You can see right here. Let me close this one. And so what's going on during jitter is that, you know, if you can see the graph lines, if I'm sort of syncing up with this line here, this 0 point, then sometimes my signal is at the top, sometimes it's at the bottom, and this is where you get the jitter. Now if I'm here, then obviously it's always high, and if I'm here, it's always low. But and this signal here, perhaps depending on interference, might jitter less, so it might only
jitter here. So if you're looking for this point, then you're not going to get that interference at all. And again, it really depends on how the particular signal is being viewed. Oh, it's right here, sorry. Whether you're looking at the falling edge or the rising edge. And again, this is just a very, there's lots of more stuff going on. But generally, you're looking for this as your synchronization. If you miss it, obviously, that's going to also change where your signal is going to end up being drawn. And of course, the reason it oscillates is because sometimes you miss it, sometimes you don't. And for horizontal jitter, what you get is the characters ever so slightly, because you have more resolution horizontally, ever so slightly shimmering this way. With vertical jitter, it's actually much more obvious to see what's going on. So in any case, I just wanted to share that with folks, how to deal with jitter if your old retro equipment, like for me, the Sinclair QL, gives you that. And again, this is more to do with my modification and the easy fixes. I got to just change the green wire to capture from the modulator. Now, the reason I didn't grab it from the modulator to begin with is because I was worried that there was some additional filtering going on, and I wanted to get the signal straight from the Motorola MC1377 chip. And it would work just as clean if I had not run my wire past the micro drives, which are causing extra noise. Anyway, that's my journal entry for today. Thanks for joining me, and stay safe.